much for thank you so much for setting aside this time to spend here with us. We have a wonderful technical session with our speaker. He's a two-time distinguished lecturer under the Society of Petroleum Engineers. So I'm so excited to have you guys here. Just quickly, I will introduce myself. And then Rajan will introduce himself and we'll go straight on into his presentation. And we will have a question and answer session at the end. I will leave it up to Rajan to allow you guys to probably raise your hands while he is doing the presentation. He will let you guys know if he's comfortable with that style. So many of you would know who I am. I am Liana Rukmirain, the current chair and program chair for the Society of Petroleum Engineers. Outside of my volunteer role, I work at NGC as the PMO lead. I'm working on a pretty cool business transformation project where we are digitalizing the entire processes within NGC and its subsidiary companies. Prior to that, I've worked specifically in the energy and oil and gas industry under the section of engineering, project engineering, working offshore. I've moved around some countries. I've lived in Spain, as I mentioned before, under Repsol. I worked in business development. I've worked with Perenco in supply chain management, operations, and I also worked in Abu Dhabi as a strategy lead in an edtech startup. And I enjoy, doing presentations as well as writing. I authored a chapter in a really wonderful book entitled Empowering Women in STEM, Personal Stories and Career Journeys. Just some meeting rules before I pass you over to Rajan. As I mentioned, I'd really like for you to have your name issued correctly on your screen. Turn off your microphones during the presentation. And if you do have a question, raise your hand. During the question and answer segment, you can easily turn on your microphone and feel free to ask your questions. You can type your questions as well in the chat and Rajan will address it. The use of cameras, we highly encourage it. And as I mentioned, do feel free to post your questions in the chat. So welcome again to our wonderful technical virtual talk with Dr. Rajan Chokshi. I will allow him now to introduce himself.
If you don't mind, allow me to share my screen, please.
Sure.
Good evening, all. It's my pleasure and privilege to present today's presentation on digital transformation, but we are going to focus specifically on the production data. So, as a brief introduction, I think you might have seen in the note, but I basically 40 years plus experience. I have worked in the production discipline all throughout. In different roles with the different companies around the globe. I have been SP Distinguished Lecturer. I spent considerable time with SP projects. Recently, I joined Artificial Lift Research and Development Council as one of the director on the board of directors. I love to travel, and actually, this talk was going to be as a part of like my visit to Trinidad and Tobago, but somehow timing did not work out. So again, I appreciate this opportunity. Um, And let's dive into the agenda for the talk. As far as the Q&A is concerned, it would be best if you hold your questions until the end. That will allow me to address the material that I want to cover. Um, I'm going to talk about what is the digital transformation, what does it mean, at least how do I understand it, what are the technologies. Then we will jump straight into what are the different data types in the production domain and specifically artificial lift. That's what I am focused on throughout. Um, and then we'll look at what are the challenges with the data as we go into the digital transformation. And I'll share a few case studies. Some of them I have been involved, others available in the public domain, etc. And I continue to be an active practitioner in this area. So it's really a privilege and honor to talk about. And we'll conclude uh, with my broad observations on this. So, when we talk about digital transformation, I mean, you cannot escape it. Very recent issue of JPT talked about how this digital transformation is progressing rapidly. And the key,
Sorry, Rajan, are you
yes, can you hear?
sharing your screen? Because I'm not seeing a presentation.
You are not.
No, I'm seeing your camera is on and I'm seeing your face.
Oh, that is okay. My apologies. Now, how about that?
Yes.
Okay, so if I rewind briefly, I'll not bore you with my introduction, but this is the agenda for the talk that I briefly described earlier. Uh, Now, when you talk about digital transformation, you cannot ask about a lot. We talk about high quality data so that we can transform our operations, etc., etc. But even before like these articles came out, we were talking about digital transformation in the form of what we used to call digital oil field. And there are some presentations going way back to 2010, where at that time we used to call it field of future. And there were a variety of other names, but it all falls under the umbrella of digital oil field. And everybody was focused more on the production increases, lowering the costs, etc. And then a recent JPT articles, and recent, by recent I mean 5 years, and we'll talk about some more recent items as the presentation progresses. But there have been announcements from different companies about how the digital transformation is helping them streamline their operations, save some money, etc. But when we look at our day-to-day job function, depending upon whether you are an operator, field operator, production engineer, process engineer, pipeline engineer, reservoir engineer, or asset manager, we all have our challenges. Uh, and we this all I can read each and every bullet, but rather than doing that, these challenges can be summarized in these few bullets. That are my equipment or wells delivering per plans? Do I have any problems or hurdles that are lurking around the corner? Then I need to plan for. Are there any failures that are coming up? And what about my lease operating costs or operating costs? And then, of course, production forecast is a very important metric also that everybody is focused on, and etc., etc. But the key thing is that we all want all of these questions answered on a sustaining basis, and we want to identify the practices so that these questions can be handled in the most effective way. And that is the promise of digital transformation. But if we go to the underlying digital oil field approach, it always starts with the sensing. And we have variety of devices that we have deployed. And by devices, I mean sensors that we have deployed at the well site, in the field site, at the facility site. And primarily, we try to measure pressure, temperature, differentials, load, position, etc. Whatever is a parameter of relevant interest. And we keep on measuring this. Not that we were not measuring this before, but now we are measuring them digitally, and we are measuring them at higher frequency, meaning we have some additional controller boxes, PLCs, etc., which not only accumulates all those measurements, but performs some basic computation or advanced computation, and then communicate them to some firewall, the cloud, where everything gets stored, and there may be some computations also occurring in the cloud. There may be some basic control philosophy available on these devices, but when everything ends up in the cloud, meaning they are accessible to a wider group of people that may not be located even in the field, there may be some data analysts, there may be some data scientists, there may be some programmers, of course, IT persons, and most importantly, SMEs who really understand the theory or underlying issues behind whatever is happening and whatever is the objective at hand. And of course, the people who focus on the supply chain, who focus on the accounting side of the business, revenue side of the business, everybody is interested in understanding how my wells are doing, is everything on the target, etc., etc. And this is the underlying infrastructure for digital oil field. Now, different companies have different level of infrastructure, but my take is that most everybody is progressing if they have not already arrived here. So most everybody is progressing in this direction. So if we have to basically look at how this digital oil field progresses, it basically starts with the surveillance, monitoring, and diagnostic. And then, as I said earlier, there are some sensors, there is some connectivity, there are some dashboards, some cloud based, and then everybody wants to perform some analysis so that there are some alarming options, some workflows are guided, etc. But the idea is that we want to have some kind of control on the processes. There is some optimization and intervention in real time. This is where we want to go eventually, meaning we can adjust the production remotely. And not that we are not doing it, different companies are doing it differently. Uh, but everybody is focused on this aspect, predictive and preventative maintenance. And collaboration room, as I mentioned in the previous slide, they are the key to performing all of this analysis as well as optimization. And then there is a AI machine learning. But now what we are seeing is that more and more of this AI machine learning aspects are integrated here, and to some extent, even they are integrated in the what I call the basemost layer of this digital oil field. So, with but everything starts with what? It starts with the data. Without data, you cannot perform any analysis. And as Lord Kelvin said, unless you measure, you do not know what is going on and you cannot improve it, right? So let's talk about what are the data types and the different varieties of data in production space. So this, as this graphic shows, on the left side is the production and maybe the drilling people in the upstream oil and gas. In between, there are some optimization, asset optimization people, modeling people, and simulation. The key takeaway from this slide is that the data loops, the frequency, the quantity of the data, the data loops are very fast for production and also for drilling folks because we are closest to the machines, we are close closest to the devices, they are somewhat slower if you once you go into the asset planning and reservoir simulation type of function. So we have to be aware that our clocks are very fast and the quantities are also higher. Now, we saw this graphic before, and why I brought it up is that I want to add a couple of other things, particularly on the sense side or the sensing side of the spectrum. Uh, Relatively recently, or maybe I should say for last 20, 30 years or so, what we are seeing is that companies are installing more and more permanent downhole gauges, whether they're electronic quartz. And the idea is to measure pressure, temperature, vibration closer to the source of hydrocarbons. Newer generation technologies, of course, more expensive fiber optic space, where we are also trying to measure temperatures across each and every meter of the entire wellbore. And we also try to listen in. So these are called distributed temperature sensing and distributed acoustic sensing. What distinguishes this fiber optics based technology from the other technologies? The volume of the data that is coming back is very, very high. For example, DTS wells, a well with a DTS fiber in it can spew out upwards of a gigabyte of data in a day, whereas distributed acoustic sensing that may approach a terabyte or more. So what I'm saying is that our sensing capabilities are expanding at much, much higher rate. And we are seeing this in our personal lives also, whereby we are getting a lot more measurement, we are getting a lot more tweets, we are getting a lot more emails, we are getting a lot more text messages. So similarly, our wells are also sending more
Okay,
and
first
more data to us because of all this
we have to
sensing.
first.
Um, Sorry, did somebody mention something? Okay, if we can hold the questions until then. Next comes the control and communicated layer, as I said, and these are typically located close to the valves in non-hazardous area. Examples are controllers, PLCs, data loggers, etc. They basically allow you to connect to some real-time SCADA systems, meaning remotely people can access the data that is collected or captured by these devices. They also have some limited autonomy in the sense that they can perform some action, starting, shutting down, slowing things, speeding up things, etc. So this is what has been like state of the art until about 5 years ago or so. And now increasingly we are talking about edge devices, where essentially we are deploying computers at the field sites. And they not only aggregate multiple devices, but they allow us to sample the data at much higher frequency. And this is important, especially when we are observing some uh, non-steady state or some transient processes. Additionally, they also perform a lot more computations at the well site because they have better processors, higher memory, better programming abilities. So what this allows us is that not only we can perform more complex physics-based computations at the well site, but we can also perform some machine learning or artificial intelligence-based data-driven computations on multitude of data streams that are being captured and communicated. This is still a developing field, in my opinion, but in next 3 to 5 years, we should see an explosion of this, if not explosion, at least wider acceptance, I should say. But coming back to the data, let's look at some of the uh, data sets. And whenever we talk about data in the context of digital transformation, we talk about more like real time, time series data, multiples of the channels, as we can see, whether it's a naturally flowing wells, ESP well, PCP well, rod lift well, plunger lift well, or gas lift well. Each well has its own set of sensors, sensing devices, and sensing streams that are coming back. And as I was mentioning earlier, we have also distributed temperature sensing and distributed acoustic sensing devices. The sensors available, which also pump out higher frequency and higher quantity of the data back. And why am I bringing all of this up? This is just to lay the groundwork where we need to be going in order to solve all those problems that I mentioned earlier. So keep all of that in mind. In my opinion, and this is personal opinion strictly, that our capability to assess the data or the assess the health has expanded a lot farther than our capability to consume, meaning making sense out of the data. And this is something that I would bring up in the later part. Now, the data is not all about the real time data. We also have what I would call discrete event data, meaning whenever we perform a workover or maybe do some sidetrack, then there is a change in the valve's configuration. We lower some different sets of accessories or equipment downhole, or we modify certain things on the surface. We can change the choke, etc. So we have variety of this, what I would call discrete data. We have production test data, we have injection test data, we have PVT data. And as I said earlier, we may have some well activity. Somebody shut some valve somewhere, open some valve somewhere. These are not real-time data streams. They do happen in real time, but they do not happen continuously. And we need to have some robust methodologies that can assimilate all of this information. And initially, people, when they look at the real-time data, and particularly those who are coming from outside the industry, they get excited about processing the real-time data streams. But if they do not pay attention to this non-real-time or discretized data, then in my experience, their approaches have not yielded the desired result. And sometimes it comes back with some almost farcical results. So, what I'm saying is that we have to figure out a way of how to assimilate this discrete data into the real time data stream. Now, if you think about it, our traditional approaches, offline simulations, offline design programs, they are not equipped they're equipped to handle this discrete event data, but in a point form, but they are not equipped to handle the real-time data streams. And we'll talk about that in a little bit. But before that, I want to show you this one slide that kind of captures what are the different types of data that can be captured for different gas lift systems or ESPs or PCP, etc., etc. Now, I understand quite a few of you might be working on the process side of the business. And on the process side, also, we have typically pressure, temperature, speed of some equipment, some amperage of if it's an electrical or electronics equipment, etc. So my point is that depending upon the context of the problem or the problem that we are trying to solve, we have a variety of real-time and non-real-time data stream. Now that we understand there are a variety of data streams available to us, let's talk about the data processing. But first, I'll talk about the challenges. And again, I'm borrowing this graphic from JPT, where the title said, all the way bad data is holding you back. And this is very true. Oftentimes, when you launch into any digital transformation projects, and you can deploy the sensors at enormous cost. You can deploy the data store in the cloud or on premise or somewhere. And then when you start looking at the data, and particularly if you have legacy assets and such, you really run into roadblock after roadblock after roadblock. And what type of roadblocks are we talking about? It could be inconsistent data, incomplete data, ambiguous data, or just plain wrong, bad data. That is a big barrier to digital transformation. So again, look at some of the field realities. So data is not always what it seems. You have to add some validation layers. Sometime the key measurement may be missing. You may not have flow rates available, or some pressure may not be available. Sometimes the measurements may not coordinate with each other. Upstream pressure may be less than the downstream pressure, for example. Measurement may not correspond to physical models. There may be some negative pressure value or negative voltage values. Data may be flatlined because of some clipping issues. There may be outliers whenever there is some disturbance that comes up. Either it's an electrical disturbance or some process disturbance. There may be some discontinuity when all of a sudden your Ymax is like not connected, or there may be some repeated value. And the problems are that we may have some older field infrastructure, like when you have something like this analog instrumentation, how you're going to bring it into the digital records, right? The communication can be an issue, which is becoming less and less of an issue now that we have covered most of the globe with cellular connectivity, right? There may be some legacy data format. They may not be in the digital form. There may be some information missing for certain time intervals because of loss of signal, as I mentioned earlier, malfunctioning measurement devices, non-calibrated devices. And then this is something human errors in capture. We may have completely wrong record. You might be saying that I have XYZ model of ESP from vendor ABC, and it may not be the case. When you pull the value, find out that, oh no, and it was just a pure human error. And all of the modeling work that you do, assuming that you have a specific set of equipment in the valve, may become invalidated. Another challenge as you capture more and more data is very well explained in this left side of this graphic from ConocoPhillips, Canada, that as people started on the digital oil field journey, what they found out is that there is a each of the function, they have their own set of data, and the data may be replicated across multiple function, and there may be the data may not be refreshed in one function, and as a result of that there is no common picture about what is actually happening. And that's where companies are focusing a lot more on what they call data integration platform, whereby data from all the different assets, different locations flow into a system where it can be validated. And some companies have even chief data officer following some of the consumer space companies in this, so that each of this function can access the data knowing well that okay, there is a single data, that this is what they call ground truth, I should say. Then there is a unstructured data. In many locations I have seen that people are conducting some business using WhatsApp or text messages, particularly those who are in the field and want to connect back to the office. So, how do you bring that in? Or there is some well site picture or video that has been captured. So, how do you bring that in? There are analog data, as I said earlier. So, some of this data cannot be easily brought into the computational infrastructure there because they are difficult to vectorize, and then you have to also put a label on it as to what does that data pertain to, what is called metadata, right? So these are some of the challenges related to the data set. Industry has been working on bringing some common data format so that the data can be easily transferred across different processing systems or different computational platforms. And that's where we have some several efforts, like late last century, Energistics started working on it. Until very recently, we were working on BitsML, ProdML, and nowadays we are talking about OSDU, open source data platform, which is supposedly technology agnostic. But still, there's a lot of work that needs to be done. Um, so we have talked about different types of data streams so far. We have talked about what are the challenges with the data. Now let's talk about what to do about it. And everybody loves to talk about AI and ML, right? If I ask for hands up, most everybody would say that, yes, I would like to use AI. And then the next question speaker asks, who wants to learn it? And then there's a big silence. And then the third question is that who is ready to learn Python? Okay. And this is something that I have been observing time and again. Actually, I'm teaching a school of a day or 2 days or even 3 days uh, with a variety of operators. And my goal is not to teach the data science techniques because by no stretch of imagination, I'm a data scientist, but to show how with some small amount of efforts, we can perform some of the computations for which we heavily rely on our traditional, very much lower tool, which is Excel, or we learn to go to Spotfire, some Power BI, things like that. So, in my opinion, we all need to, if not learn, but at least understand what are the possibilities, what are the capabilities. And this field is advancing so rapidly. And some of the slides that I'm going to show next will replicate that. Now, one thing we have to keep in mind, and this is from a Google paper, what this shows is that whatever we call machine learning or artificial intelligence code, it's a very, very, very small part of the entire computational infrastructure, right? Lots of effort needs to go into data collection, data verification, data processing, right? And these are the areas where we have responsibility, in my opinion, and we have a role to play. And by we, what do I mean? The practitioners in the field who own the assets, who are expected to make sure that this asset perform as per the organizational like requirements or the profitability expectations. So why not to deploy some of these advanced computational techniques that would allow us to make sense out of this flood or the torrent of real-time data streams. And that is what. So after kind of talking about data streams, talking about data challenges, now let's talk about opportunities because that is where the exciting things are going to happen. And by the way, what I'm going to talk about is based on my limited experience here. It's just a sampling. Many, many more examples have been deployed than what I'm going to discuss here. And possibilities are in our heads. Okay. What people refer to as use cases. So you have to look around whatever is your domain or whatever is your workspace, what data streams are entering into that workspace and what decisions you have to make. And then I can assure you can conjure up some tool set based on that to perform faster, better computations. Okay, so let's talk about one Power BI visualization of combined data set. And this is for ESP valve. And what I'm showing here on the bottom are some real-time measurements coming from an ESP well, like intake pressure, discharge pressure, current of the motor, casing head pressure, flow line pressure, etc. Now, this data stream by itself is very rich, but if you want to figure out why my ESP is failing or what is going on, then you need some additional data. And this is where the discrete data, like what I'm showing above, comes into play as to when did we perform a valid test? When did we change the completion? Or when did we change the perforations? Or when did we install a specific model of the ESP, etc., etc. So when you have this two information overlaid, and this is, by the way, a very simple example, and I'm not saying that you may not be doing it, but the idea is that when you have such visualization, then you can get answer to the questions like this very quickly. Did new completion improve production? Do we need to increase the gas injection? Is it a time for another scale removal operation? Or did we conduct too many hot oiling jobs, which eats up our profitability? Or should we move a well to a wet header because now the water. So these are the type of timeline related questions that can be addressed using this type of visualization. Now let me switch gears and talk about one of the problems that a colleague of mine I worked on when we were at Weatherford. That was a Permian, and this was a gas lift valve. It was a condensate valve. So there are some downhole gauges that have been lowered. But the problem that we were trying to address was not to look at the real-time data stream. Of course, you can look at the real-time data stream, and with the visualization, you can figure out what are the operational things going on. Like here, we are seeing multitude of slugging events happening, which has to do with the configuration. But our focus in this study was more to look at how we can come up with a better estimate of static bottom hole pressure and productivity index. And that's where we looked at all this real-time data, and we used some of the, like in this case, you can see it's a Minitab software. And also we kind of mashed the uh, calculations from another software, which is a physics-based calculation, to come up with uh, better estimate of static bottom hole pressure and productivity index. And you said, wait, what is a big deal about this, right? And let me show you the big deal. Here is a very similar another example, and I have performed quite a few of such. And what I'm trying to show you is that in an unconventional valve, and this is not a condensate valve, this is a liquid producing valve. As you can see, it's a high producer. Just over the time period of 3 months, there is significant productivity decline. And if you do not have a rapid estimation of productivity index and static bottom hole pressure, then your models are likely to be wrong. And that's where what I'm showing here on the right side is just the 200 lines of the code, including all the comments and everything, just 200. And I can process hundreds of wells data that have very high frequency of well test measurement, and I can implement this hybrid algorithm, and on my laptop I can perform this computation and spit out this type of plots in less than 10 minutes for 100 wells. So that is the power of using some of these new generation tools that allows you to perform the analysis. And this is required, as I pointed out, in unconventional well, your productivity drops very drastically, right? Now, this procedure can not only be applied to unconventional, but it can be applied to conventional wells as well. You can analyze a history of a well over the time period of maybe 10 years, 15 years, etc. I'll give you another example, what I call low-hanging fruit. Many companies have worked on this ESP failure detection and prediction because of the cost of the ESP failure. Not only the equipments are more expensive, also the deferred production costs are very high. And there are quite a few case studies, and I'm putting here a sampling of case studies that and what this shows each of this that there are some set of static data, there are dynamic data, and then there are calculated data. And then each of this set of researchers have their own ways of coming up with a solution. And by the way, no, a final chapter in this is not written because anytime you come up with the model, it is specific to a particular group of valves, meaning you cannot just plug that model and apply it to another location just like that. Okay. Now let me talk about another predictive maintenance model that was published for rod pump. By the way, I'm just including here what has been published. I'm sure there are many more models that have been developed uh, and that have been deployed in different companies with different degrees of success. But this again shows that how we can use human expertise to train some of this algorithm to identify what type of card it is, and then it can detect what condition is experienced downhole for the rod call. Okay. Here is another example of plunger lift where virtual flow meter has been developed. This was a part of, I think, PhD thesis work done at University of Tulsa. And there are some very interesting outcomes that you cannot use brute force approach, utilizing raw pressure and flow rate data, right? You how to use physics guided feature. And that is where we as practicing professionals have an important role to play. Okay. So, okay, I can keep on giving you example after example, but let me talk about something that has come up recently. Just last week or week before last, there was this article in JPT that how Devon Energy worked with another software company and a cloud computing firm to estimate automatic bottom hole pressure, downhole pressure. And you saw flavors of this earlier when I showed you one work that we did long time back. There was another article about the same time when artificial neural network was used to predict discharge pressure of ESP. Right? This is from the Middle East. This is from USFA. So this tells you that there is a need because not each and every well will have a downhole pressure measurement device. In that case, how do we come up with a better predictive models that will tell us in real time how our well is, what is the health of our well downhole? And that's why the companies are investing significant amount of money in developing this type of machine learning and artificial intelligence approaches. There are other things being done, like, for example, earlier this year in JPD, there was this article about computer vision and edge computing. I mentioned edge computing earlier, what type of benefits it can bring. Computer vision is another area which is, I don't think it has seen as much of adoption, but it is going to increase. Because when you think about it, quite a few of our analysis approach are based on the recognition of certain shapes, certain forms, etc. So computer vision can be helpful. We are using computer vision all the time whenever you're driving Tesla or some vehicle like that that has some object detection technology. This is something that is gaining stream, and I can tell you, I've been using large language model like ChatGPT and this is not a laughing matter. You can use something like this for not only research but for coding. And this is where I see the value of these tools. Like you can prompt it that, hey, write me a small program that will help me perform this computation. And it takes less time than what it takes for you to type this prompt into ChatGPT or Gemini or whatever is your flavor of LLM. It will give you back a Python code or Julia code or whatever type of code in no time. Now, of course, those large language models are known to hallucinate also. So meaning you have to also perform some due diligence. But these are some of the interesting paradigms coming up. And very, very recently, EDNOC came out on March 8th and said that by deploying some of these technologies, they are realizing $500 million in value. Right? So each of us, it behooves of each of us to look into our own workspace and see where I can find such value that I can contribute. So, in conclusions and recommendation, production data is a must for enabling digital transformation. So, we need to think in what ways will we contribute to ensure sufficient and high quality production data, whether we are data generator or data custodian or we are consumer of that data. How do we use these real-time data sets? So, what is a recipe? You can infuse this real-time data stream with offline physics-based approaches. You meaning production teams or people who are in these roles on the domain side as a subject matter expert, they need to understand and embrace emerging data science paradigm. Don't shy away from cloud computing, edge computing, Python, neural network, LLM. I'm not saying that become master in each of them, but just use some of this large language model to understand. And trust me, I mean, you can ask it that, hey, explain to me as if like you're explaining to fifth grader, and it will explain to you, right? On the other side of the equation, data scientists, they also need to understand field and domain side of it, meaning they need to incorporate this into and work with production professionals to develop reliable, explainable models which deliver business value. And that brings me to the end of the presentation. Here are my contact details. Let me bring up the chat if there are any questions there, or else you may go ahead and unmute yourself and ask the question. We are open for Q&A.
Yes, guys, don't be shy. Ask your questions.
If not, then I may have some questions for you. And I asked that earlier, right? In what ways will you contribute to ensuring sufficient and high quality production data? How do you see this data? Let's have an open discussion, if not question form, right? How do you plan to use some of these tools that I talk about? Or do you see possibility of using these tools? Now, I know quite a few companies do not allow using some of the LLMs in the company space, but you can always use it on your personal time and educate. There's a question Avinash is asking. You mentioned using Chat GPT for coding, but are there any implication of this in terms of copyright issues? As far as I know, no. Actually, many of the technology companies have made it mandatory. I was attending one of the TED talk recently, and the CTO of this company was saying, and this is a big AI uh, related company, and he said that if you are working for me, meaning if you're working for my company, and if you're not using Copilot. Now, Copilot is, of course, Microsoft terminology, but what he meant was that coding, taking the help of AI to deliver a better code. If you're not doing that in my company, then you do not work for us. That was his statement. And I can vouch for that. I'm not a greatest coder, right? I have coded all throughout my professional life, but I'm more of a kludgy type of person. And I can tell you, it has improved my productivity tenfold. Having said that, I also want to caution that you cannot just take that code and run with it. you have to have a little bit of understanding because that code is likely to have some mistakes. But one thing is for sure, if you interact more and more with ChatGPT, somehow ChatGPT or Gemini, I run both of them side by side, by the way. And then someday I'm going to run Mistral also on my laptop. What I do is that I ask the same question of the both LLMs, and then I review the Python code. I try to understand how one is doing versus another one, and try to get the best of both the worlds. And what I'm finding is that I'm making less and less mistakes, and I'm arriving at my final destination a lot faster as a result of that. I hope, Avinash, that answers that. I know you asked about copyright issues.
Hi, Rajan, it's Kieran here. So I guess just kind of to continue discussion with Avinash, I know like a lot of companies say, if you're using ChatGPT, you shouldn't be putting in, proprietary data for the company, like, actual production figures, these things. So I know for myself, because I actually still do what you're mentioning in there, using ChatGPT for coding myself. But I would like use it in terms of, okay, so like if I'm doing a program, I'm using production data to get this output, I'm running across an error in my case, I'll go to ChatGPT and say, okay, I'm getting this error, and I won't input the actual data. I'll probably just input the error, some samples of the code I'm writing minus the, confidential information and data. And it still helps. It helps you, write clearer, more concise code at times,
Yes.
yeah.
And that is one way. And now some companies, about 4 weeks ago or so, we had one forum here in Dallas where people got together from all disciplines of upstream to talk about what will be the AI and machine learning progress in 2030, right? So forum is about future. And what I learned in the process among the discussion, it was a 4.5 days of discussion. What I learned is that quite a few companies here in the States, most of the people were from the States. There are some overseas partners. Quite a few of them shared that they have their own in-house version of large language model. I wouldn't say that it's a chat GPT, it could be something else, but quite a few of them are deploying that. And I agree with you, Kiran, about not putting in your company's data into that. But what you can do, there are, by the way, you can even ask ChatGPT that give me a Python script or whatever to anonymize my data or to create a synthetic data set. Okay. So that way, if you are going to plug it in, then you can plug it in this synthetic data because you're not looking for answer to how that data solution comes up, but you're looking for a workflow answer. So then you can just put in like a synthetic data for that purpose. That is if your company policy allows.
Hey Rajan, this is Miguel here. So just to chime in on what Kiran and Avinash were speaking about, I also use ChatGPT um to help develop templates for writing code. And what I have found that works, I use it in tandem with like Gemini or another one called Claude. And sometimes let's say you ask ChatGPT to give you a template. Many times it doesn't work right off the bat, but you can actually paste that template into like a Gemini or Claude and say that you're getting this error, and then they will work off of that original template. And more times than not, it works the second time around.
Yeah. Great point, actually, Miguel. What I have found is that oftentimes the answer improves because of my prompting, meaning I did not formulate the question that well to begin with. Uh, and once I get the answer back, and some of them, at least the co-pilot, gives you some explanation also, right? Which is a chat GPT co-pilot. And So I try to read that explanation, and then I understand flaw in my prompting, or I see how I can change the prompting. By the way, this is turning into all LLM related discussion, but coming back to the digital transformation, I think we have not many more things. I'll tell you, I mentioned the data issues, right? Can we not put some algorithms on the sense data, the data that we have measured, to make sure that that is a copacetic, that's a good data, right? Meaning we can track the health of these sensors using some of these models also. Right now, it is being done with human intuition, and but can we not automate all of that? Whereby, so there are quite a few interesting things. I'm very excited about this work. Okay. Buddy, any other question?
I have one for you. So I know you showed like during your presentation a lot of those snippets from the article. So digitization has led to this much billions of dollars, due to the AI. So like how do you accurately measure that? Because like I work in the digitization space, and a lot of the work we do, we have to show success stories about okay, the work we're doing is actually contributing to the company's bottom line, and I find that really difficult to do. Like how do you
Yes, I think again,
show
it
that?
requires a little bit of very, very good question, Kiran. Actually, how do you come up with a business value, or how do you prove the business value to the people who are supporting you? And this question actually came up in one of the in-house workshop I conducted for one company in Latin America, right? Whereby 2 years of the effort that was spent on developing some machine learning, and there was no utilization. And so I said that why don't you go back and ask the stakeholders why they are not using it? But coming back to your question, I'm not trying to circumvent the question here. So I would look at it this way. Okay, what problem I'm trying to solve? Has that problem ever been solved before? Because some of these real-time data stream related issues, like let's take the example of downhole bottom hole pressure estimate, right? I think I showed uh, this case study. How would Damon Energy justify some other company to solve this problem for them? So they will say that, okay, if I know my bottom hole pressure, then I know how particular well is performing, meaning I can back allocate the production on daily basis because I know the downhole pressure. Just an example, right? Meaning I can right now, because of the faulty back allocation, I might be losing the production in some of the wells, or I may not be appropriately adjusting. Another way I can look at it is that, okay, I improved this computation process. Earlier, it used to take me to perform this computation in XYZ software a half a day, right? And now I'm able to do that in less than 2 minutes. So what is the value of my time? And how am I able to alert my higher ups about some anomalies or some challenges? So that is another way you can come up with a value. Uh, Third way you can come up with the value, like why people are working on the ESP failure prediction problem. Right? It's not that they are going to pull the ESP out of the hole the moment they realize that it is going to fail in 15 days. That is not the intent. Their intent is that if I know that it is going to fail in 30 days, then I can start planning for it 30 days in advance and not wait until it fails, right? Meaning I got a leg up on saving my deferred production, because in some locations you may not be able to order the equipment or line up your workover crew, etc. So you have to, coming back to your question, you have to look at the what problem you're addressing, how it was done, or whether it was done at all before. And now that it is being done faster, what is the value there? I hope that answers. But if you have some specific use cases, we can have offline chat, and I'd be happy to explain to you how I would do it if I was in your shoe. But then your data is going to leave your office. No, I'm just joking. Just you can come up with a
Yeah.
broad use case description, and then we can brainstorm. You know.
Okay, thanks.
Okay. Any other questions, comments, concern?
I guess I have one final one. So I kind of hugging the
Yes.
question. So do you see the need for us to like, if you know you want more to digitization, to like learn in depth the statistical methods for like machine learning, or do you see that just being simply tools that would be developed and pre-coded, and we just apply those machine learning tools to data we have to get increased value?
So for that, let me go back to this one slide that I showed here. What comes and what the way I understood your question was that where this will all go. Is that correct assessment?
Yeah. So like, do you see the need for like I know a bit of machine learning, but I wouldn't know the exact statistical equations behind, say, a random forest method or a neural network method. So
I
do you see
see.
me needing to learn that to move more into digitization? Or do you see those tools
So,
being developed? Yeah.
so
And
you're
just
talking
applying
about
them.
explainability, correct? That can I explain? Now, in my mind, we have been using regression models all our lives. Most of the time, whenever we plot straight line, and we have been doing it. And whenever we do things like that in 2 dimension, it is easy to explain. Good and bad thing about some of this real-time data-driven machine learning approaches is that you are not looking at just two things. You're looking at maybe 10 or 15 or 20 things at the same time. And you are absolutely correct that it becomes very difficult to figure out the cause and effect. And that's where there are some things like covariances and you can explore. But particularly when you go into deep learning type of paradigms, it becomes even very, very difficult how it works and explain it. And I do not have a good answer for it other than I just look at it this way that I need a tool to solve the problem. Now, I have been solving this problem using some heuristic, some gut feeling, or using this data-driven approach. I would take data-driven approach followed by heuristic, followed by gut feeling in that order. Right? And that's why you can implement some of the heuristics into this machine learning. I don't know whether that answers your question.
It helps. Yeah. Thanks.
Okay.
Do we have any more questions?
I have one more. The last
Yes,
bullet
Miguel.
there, it talks about autonomous operations and demanning, right? You know, that might be a concern for some people because would it mean less jobs in the future? And what could the present day engineer do to keep up to date with these things and to prepare themselves for such a future?
Yes. And this is a valid concern. Now, if I have to just give you off the cuff answer, then I would, and that would be somewhat insensitive too. I would talk something like this, that think of the people who were driving the horse driven buggies. And when the steam engines were introduced, first time, this horse-driven buggy people, the people who are making the bridles, the people who are picking up all the manures from the roads, they all said, okay, what we are going to do? There is I do not have to make a bridle for this steam engine, right? Or so I think this is a big paradigm shift. Uh, and compared to those previous industrial shifts, this one will be a lot faster and it is gaining momentum every day. The only way I can see is that you have to stay ahead of the curve. Now, this is a jargon I'm talking about, meaning you have to be knowledgeable or understand, you have to understand some of these things that are happening out there, right? And try to stay ahead. One thing is for sure, despite all of these real-time data-driven approaches, LLMs and whatnot, there will always be a need for somebody who understands processes, who can prompt it, who can ask the right questions. Now, you can stretch this and say that, okay, there will be some fully autonomous, but I do not know. But upscaling is the answer in my mind. Okay. What are your thoughts?
Yeah, I agree that you have to upskill and keep up to date with just everything that's happening and the latest.
If there are no other questions, then shall we conclude?
Yes.
Okay.
So
All right, back over to you.
thank you so much. Thanks, Rajan, for a wonderful presentation, and thanks for all the participants for your questions. It was quite informative, and I'm sure companies are working on all the right policies to enforce, the proper use of the chat GPT and to ensure that they gain all the business value that is required, as well as training employees and people with this cultural change would also help with, utilizing the tools in the best or optimal manner. So thanks so much, Dr. Rajan. And I'd like to request you guys if we could just take a group shot. So if you aren't too shy and you're able to turn your camera on, it would be, we will highly appreciate it. I know some of our participants dropped off earlier, but that's okay. We had a nice intimate session today. I'm sure you guys will agree. So if you can quickly, if you're able to quickly turn on your camera, we will appreciate it. Cami, Talia. Anyone else? Okay. Everyone's ready. Hi, Rafi. Good to go?
Okay. Thank you very much. You all have a good evening.
Thank you.